All right, you are welcome to today's teaching with your teacher, Christopher AGK Anakwa, your chemistry teacher. I want us to start by allowing you to observe your car battery. Observe your car battery or any car battery around you. You observe that the so-called car battery is well set up in a way that it has content inside, something inside. It has a wall that house two things that looks like pole at the end of it. And usually, if you want to charge it, definitely it's being connected. That two pole rod or iron at the two ends is being connected to a source, electric current, through the two pole. Still remember that I said that it has a content. Of course, we believe that what is inside is what can allow the electric current to pass through it. That is why it can able to conduct or generate heat or electricity that it can be used to power your engine or even anything around that you want to use it for. Use it for power. Now inside that thing, we have ions that is being broken. But the whole process that happens in that particular car battery is what we call electrolysis. Those substances that is inside will break, it will decompose into ion that enables it to generate electricity. This will lead us to the topic we have today called electrolysis. Electrolysis is expected that by the end of this particular class, we'll be able to define electrolysis and also define some terms that relate to electrolysis. Some terms in electrolysis like electrolytes, electrodes, which are the anode and the cathode. You also define electrolytic cell. It's also expected that by the end of this particular class, we'll be able to differentiate between electrolyte and conductors. Electrolyte and conductors. Then finally, you'll be able to identify factors that is being depended on the preferential discharge during electrolysis. Factors that affect discharge of ions during electrolysis. Let's begin by saying, what is an electrolysis? What does electrolysis mean? Electrolysis is just the chemical decomposition of compounds, which takes place when an electric current is being passed through either a solution or a molten form of a compound. Remember the car battery that I talked of? Electrolysis is the decomposition of that compound inside, the content inside, just like the car battery I'm using as an instance. The composition of the compound inside. When electric current is being passed, connected to it, the decomposition of it that enables it to allow the electric current to pass through it. That in solution or in aqueous form. That aqueous form means that it will not be in solid state. It must be in solution or in aqueous form. That is what we call electrolysis. That means decomposition of compounds when electric current is being passed through such a compound in aqueous solution or in solution. Now, other thing we need to know, in other way, we can put it that electrolysis is just the breakdown of substance by electric current. Breakdown of substance by electric current. When a compound is being broken down by an electric current. We call it what? Electrolysis. All right, let's look at some terms we need to know very closely in electrolysis. Electrolytes. Still remember that in our last video, our last class, we talked about electrolytes. We said that electrolyte is a compound. Electrolytes are compound, either in solution or in multi-form, which conducts electric currents and is decomposed at the anode, at the electrode, in the process. Electrolytes are compound that are in solution or in multi-form, which conduct electricity when currents are being passed through it. But still remember, they will decompose at the process, at the electrodes. Now, example of such compounds or such electrolyte, as we said in the last class, is acids, alkalis, which are soluble bases or soluble salts. These are the examples of electrolytes. So inside your car battery, we have acid there. It's an example of electrolyte. So non-electrolyte does not conduct electric current in this manner. Something like sugar, alcohol, and trichloroethane. All right, what is electrode, or what are electrodes? Electrodes are those conductors. They are metallic conductors, or you can say they are poles of carbon or metals through which an electric current enters or leaves the electrolyte. Using the example that I started from the beginning, you see there's two poles in the car battery that I shown when we began. One pole is on the one end, the other one is in the other end. Those two poles, the two poles are the entrance and exit, entering and exit of electric current. Current enters the electrolyte through that pole. We call it electrode. That two things are called electrode. Current enters and leaves the electrolytes through those electrodes. So we call them electrode, and they are metallic objects. They are metallic rods or poles. Now, in that pole, there are two. One is anode, one is cathode. Anode is the positive electrode. We have positive rod there, positive metal there, positive electrode there. We have negative one. The way we have positive charge and negative charge. So anode is the positive electrode by which current enters the electrolytes, or by which electron leaves the electrolytes. Now still remember, anode is positive electrode, cathode is negative electrode. Current leaves the electrolyte through cathode, but current enters the electrolyte, that solvent, that substance, compound inside that cell. Current enters it through the anode, the positive electrode, but it leaves it through the cathode. That is what you need to know. Then, what is electrolytic cell? Electrolytic cell is just like a container. The car battery, the cell, the container, the wall of that car battery that you can carry. That is what we call electrolytic cell. Using that one as an example, a container that must consist the electrodes, which we saw there that it consists of two electrodes, the positive and negative, which is the anode and the cathode. It will consist of two electrodes connected to it to electric supply. It's through that two end that electric current will be supplied to it. So the study of electrolysis is concerned with all these reactions that take place in the electrolyte at the anodes. So the electrolytic cell, in the electrolytic cell, inside the wall of the container, inside, everything that happens there, oxidation occurs there, reduction also occur there. So electrolytic cell is the wall of the container that carries the content, which is the electrolyte, and also carries the electrode, and everything that happens inside it is what we call electrolysis. All right, let's differentiate electrolytes from a conductor now. Differences between electrolytes and conductors. Conductors, of course, they conduct electricity. Electrolytes, of course, they conduct electricity. But what are the differences? Electrolytes are compounds, basically acids, bases, and salts. It could be any of them, while conductors are purely metals, usually metals. They are elements, usually metals. They are metal, they are metallic objects, they are solid objects, they are metallic objects, while electrolytes are multi or solution. It will be multi-state or solution, but they are acid, bases, or salt. Any of them can, it could be. Then another difference between them is that electrolytes used to be in multi-state or aqueous solution, while that of the conductor are usually solid. Another difference is that electrolyte decomposed by electric current. And the process, it gets decomposed. But conductor is not like that. It does not decompose by the passage of electric current. As we know, our electric wires, our aluminum wires around us, or any metallic object, yes, if you touch it, it will shock you, or it carries the electric current, but it does not decompose. It remains what it is. So that is another difference. Another one we can also point out is that ions carry the charges, or carry the charge. Ions are the current carriers, while electrons carry the charge, carry the current in the conductor, while ions are the charge carriers. They are the ones that carry the current in the electrolytes. So these are the ways in which we can differentiate electrolytes from conductors. Okay. Now we need to look at how does ion discharge during electrolysis. We have what we call preferential discharge of ions during electrolysis. They do not leave the electrolytes or the electrolytic cell anyhow they want, or if I want, I will just leave. No, they have preferential means of living. We have order. We have things that has to be considered, factors that affect their living. Number one is position of the ion in the electrochemical series. The ions present in the electrolytes, definitely two positive, not more than, at least more than one. At least two positive ions will be there, and the two, because definitely two compound, water is already there. Another compound that will be added will also have its ion. So the position of the ions in the electrochemical series affects the particular ion to be discharged. Another one is the concentration of ions. Then lastly, another factor to be considered there is nature of the electrodes used in such electrolytic cell. Position of the ions in the electrochemical series, the concentration of the ions in that electrolyte, then nature of the electrodes used could affect the discharge of ions. Now let's take them one after the other briefly. In electrochemical series, as we said before in our last class, are the arrangement, order of reactivity of metals or ions, cations and anions, the order of their reactivity is expected if every factor are constant in place. It's expected that if two cations, as an example, maybe sodium ion and the copper ion or hydrogen ion in the cation aspect of it now are being found in a particular electrolyte, it's expected that the one below will leave the electrolyte and leave the one at the upper side, higher reactivity, to remain in the solution. So ions lower in the electrochemical series are discharged in preference to those higher in that series. The same thing at the positive at the anions. It's expected that those are lower will be easy to be discharged in normal condition, in ordinary condition. So consider their position in the electrochemical series in order for you to know which one will leave the electrolyte, will go off, and the other one will remain. So position of the ion in the electrochemical series affects the discharge of ions during electrolysis. Next one is concentration of the ions. The issue of concentration of the ion is being promoted, or it takes place when we have two ions that are competing ion closely positioned in the electrochemical series. So increase in concentration of a given ion tend to promote its discharge from the solution. Ordinarily, still remember that we said that position of the ion in the electrochemical series affects the one that will go off. The one lower will go off, but when they are closely and when they are close in the electrochemical series, the concentration of the ion will affect the one that will be discharged. So, but if their distance is afar, if the distance between they are not closely ranged, no matter the concentration, it will not be highly minimized. The discharge, definitely the one lower will go off. Example is when we have the electrolysis of brine. Brine is concentrated sodium chloride solution. Ordinarily, the anions there, we have chlorine ion and the hydroxide ion. Ordinarily, chlorine is higher than hydroxide ion, but because of the concentration of hydroxide ion, it will be discharged in the anode in preference to hydroxide ion because of the concentration in the electrolytes. Why? Because two of them are closely ranged. They have close range in the position of the electrochemical series. It can only work when the position of the two ions to be considered is close range. Now, when you go to the same reaction now, the same in electrolysis of brine, when you go to the cathode, which has to do with the cation, we have a concentration of sodium ion there. We also have hydrogen ion. But of course, we know that the concentration of sodium ion there is high. But the range, the distance between the sodium and hydrogen ion is very wide. So, in spite of the fact that sodium ion is highly concentrated, but yet hydrogen ion is still preferentially discharged because of the great distance between the position of sodium ion and the hydrogen in the series, which has rendered the effect of concentration less important. Still remember, it works when the two ions to be considered is closed. They are competing in their position of electrochemical series. So concentration can affect it, but when the ions are closed in their position. All right, the next one, the last one of the factors to be considered now is what? Nature of electrode. Of course, we have several electrodes. We have talked about the electrode, the metallic wires. We have several electrodes to be used, but the nature of electrode used affects the one to be discharged. Electrode, we have two types of electrode. We have reactive electrode and inert electrode. Inert electrode are the one that does not participate in any of the reaction, while reactive electrode participates actively in the reaction. And because of that, the type of electrode used in a particular electrolyte or electrolytic cell affects the discharge, the particular ion that will be discharged. So some common inert electrode, the one that does not participate in the chemical reaction. Common example is platinum electrode. We have carbon electrode, which is normally graphite. We have gold and rhodium. So these are the inert electrode we have. We still have some reactive electrodes, which are zinc electrode, copper electrode, lead electrode, and silver electrode. These are reactive electrode, they partake in the chemical process, in the reaction. They partake actively in the reaction. And anyone that is being used determines the kind of discharge that the particular ion that will discharge because of what they do in the reaction. So this electrode influence the discharge of ion because they have strong, they are strong to certain, they have strong effects on certain ions. They have strong effect on certain ions. Still remember, we are talking about factors that affect the preferential discharge of ions in during the electrolysis. Okay, so far we have said that electrolysis is the decomposition of compounds which take place when an electric current is passed through the electrolyte, either in solution or in molten form. Electrolysis is the decomposition of compound which takes place when an electric current is being passed either in solution or in a multi-state of a compound. And we have also discussed the terms that are associated with electrolysis, which are what? Electrolyte, electrode that has to do with anode and cathode, and we also talk about electrolytic cell. All right, you are to take this particular assignment. WAEC 2004 number 4 question says, explain briefly each of the following: A, anode, and B, cathode. And 2016 number 1 question says, what factors determine the selective discharge of ion and the electrodes during the electrolysis? And finally, 1996 number 10 question says, give one difference between a conductor and electrolytes. For what we have done so far, for further inquiry and discussion, you can contact me through my contact address, phone number, which is 080-655-73229, 080-655-73229, then or email me at christo116@gmail.com. For further studies, you can use your essential chemistry, understanding chemistry, new school chemistry, compiled past question answer, and others. All right, thank you for being part of this class.